Today we have having Mr. K.B. Ratnakar Reddy, who is a young entrepreneur in the field of highway and transportation engineering, who is with us to deliver a guest lecture. So before that, I would like to welcome all of you and K.B. Ratnakar Reddy on behalf of all of us. We also have Kavita, Ramchandra sir and Manish sir. Welcome to you all. Just a brief about Ratnakar sir. He is a life member of Indian Roads Congress, member of Indian Concrete Institution, and a past elected council member of IRC. Mr. Ratnakar Reddy has over 20 years of professional experience in the field of highways and urban infrastructure, covering preparation of feasibility studies, DPR, preparation, etc. He comes with an immense experience in transportation and infrastructure projects. He has advised many government authorities, contractors, and concessionaires on viability of PPP and DBFO road projects. He has written and published several technical papers and given technical lectures at various engineering colleges and forums. Presently, Mr. Reddy is the managing director at Infrasupport Engineering Consultants Private Limited, a company founded by him in 2007 and currently employs over 260 employees, engineers who are working on several road and urban infrastructure construction projects in Karnataka and all over India. The company is listed as most promising consultancy companies in India by Consultants Review magazine July 2015. His company caters to design PMC consultancy services in areas of roads and highways, traffic and transportation, urban infrastructure, buildings, structures, BOT, PPP projects, pavement management, and the list goes on. Mr. Reddy has received several awards such as BID International Award for Quality and Management, Geneva, Switzerland, 2015, ICI Young Engineer of Karnataka for the year 2015 for outstanding work in civil engineering, Young Entrepreneur Award from Indian Council of Commerce and Industry, Delhi 2016. He is also the recipient of Professor C.E.G. Justo Gold Medal for outstanding performance in ME, Highway Engineering, Bangalore University 2001. Here's wishing him all the best and many more. If I have left out anything, you can add on in the
That's a too long introduction.
And he has published over 13 papers, 13 technical international and national journals and conferences. He enriches his flair for teaching by delivering guest lectures on invitation, and also he has been a resource person for several training programs. He's our senior at college and has always been a well-wisher for us. Welcome to you, Ratnakar.
Thank you. Thank you.
I request Ramchandra sir to please hand over this small gift.
See, one small detail, of course, it was not in the list, but it's okay. Is that, I and Dr. Mallesh have the pleasure of welcoming one of both of us former student. He was our student in SIT.
I would have said that actually. It's actually a pleasure, getting a welcome from your own teacher. Thank you. Now laptop you connect ಮಾಡಬೇಕು. Okay. So Ramchandra sir and Mallesh sir are my teachers in SIT. I did my engineering between 1994 and 98. And when I actually from first year, when we entered in third semester, I think sir has left for PhD. That's the time.
Yeah.
Mallesh sir used to teach us survey engineering, extensive survey and all. Dr. Kavita and Dr. Jaya, my juniors in UVC. So it's a small world.
Connected. Help him with that.
Hello. Audible there? Last bench? Okay. So, thank you, Dr. Jaya, for a very long introduction. It's been a homecoming for me. We used to be regularly, about 6 years back, at least once or twice in every semester, I used to come and interact with the students. After that, become little hectic with the work and difficult to manage my schedules. So it happens couple of times that I say, okay, this day, this time I'll come, and then I got got different priorities, so I said it doesn't work. Without integrity, nothing works in life. So that is the principle for anything and everybody. I have not seen anybody succeed in their career or life without an integrity. Maybe not 100%, but integrity is very important. I don't know, Dr. Jaya said to talk on EOQs, tendering, part of DPR and all. Just want to know, speaker told me you already finished their 2 years course, right? How many of you already completed your
Yes,
course?
most of
Only
them are
you?
the first years.
Two
These are
semesters.
first year students.
But all others are?
Them 2 semesters.
Second semester students.
Yeah. So all others are second
Second
semester, right?
semester.
So what is this been already taught in the DPR? Is there a part of syllabus?
Yeah, it's a part of the syllabus. They have
Okay.
been taught about the stages of DPR preparation and EIA based on that, and the traffic studies, geometric design related to that. All that is being done.
So what I do, I'm not a teacher, okay? So like academic teacher, I'll not be going on a content-wise step by step. I would take to one of our projects of the DPR of the National Highway. Exactly the presentation what we made to the authority. Go slide by slide. I'll start talking more. I'll show the slides. Any point of time, any one of you want to know something, just raise your hands and ask the questions. It can be a silliest question. It can be out of that slide. It can be anything. Okay, don't mind. You're all learning. You're all students. Okay, I don't expect any intelligent question from you. Anything is fine. Feel free to ask the question. I am here to interact with you. You should be able to learn as much as I would like to learn from you also, right? So long back we did a DPR.
Somebody can help you. Shikhar?
I think I can use this, right?
Yeah, that's what.
Okay, fine. So. This is the receiver for this side.
Is that USB connected?
Yes. Oh. Yeah, it's a USB connected.
USB is connected.
Distance is not key.
Okay, so this is a road project in Rajasthan, in a district called Barmer, close to Pakistan border. And recently, about 4 or 5 months back, if you have read newspaper, Nitin Gadkari, your transport minister, has landed his aeroplane on a road. Any of you read the news? That was the road we designed. That is the first road where government wanted to build runways, build the carriageway as a runway also so that an emergency landing can happen. Now they have made mandatory now in the selected highways. So it is for a strategic purpose. And since this road was also a border of Pakistan, we have designed a runway also in this. Okay. Now, typically when a National Highway Authority of India or Ministry of Road Transport Highways or Road Development Corporation in Karnataka, any state, when they appoint a consultant like us to prepare a DPR of a project. That project road can vary from say 10 kilometers to 100, 150, 200 kilometers. For every road to prepare a DPR, they expect a team of qualified civil engineers. There should be one team leader, there should be a qualified highway engineer. In our project, we have Colonel Balachandrudu was my team leader, he's my employee. He's a retired army engineer. And you will have highway engineer, traffic engineer, transport economist, payment engineer, quantity survey engineer, geotechnical engineer. These will be the key persons should be there in any road project for a DPR. And then a lot of young engineers like you, or maybe few years of experience will be there. Okay. You see, this is the key map of the project. You see the Pakistan there, Pakistan here. This is the border, and this is our territory, India. This road starts from here like this all the way, and then ends here. Okay. Now it's about 200 kilometers. Actually, about another 200 kilometers is the road. Now, so Gagaria to Sata, one section. The other section is another 67, 197 kilometers is the project road. Okay. So what we do first, we have to understand what kind of road, from where to where. If you know, if the 200 kilometers, it is not constant, it is not homogeneous. You will have different kind of villages, towns, settlements will be there. So we break down, and also depending upon the carriageway width, some length may be intermediate, some length it may be single lane, some length it may be 2 lane, 4 lane. So what we do, based on that we make homogeneous sections. Okay, this point to this point is this characteristics. You see what we have done. There is an ROW varies from section to section, and in all this, what is the kind of culverts, bridges. One thing what we observed in this road is absolutely very least cross drainage structures. The same road would have been in like anywhere in South India. For 200 kilometers, you would have at least 150 bridges, culverts, minor bridges, major bridges. There it is a complete desert. Rajasthan is this part is desert, and sand dunes were there. Not many cross drainage structures because there is no rainfall and there are no nala streams and all. So first thing we have to do, what is the existing right of way, ROW available is very important nowadays. If you have seen everywhere, land acquisition is a big issue. Everybody is interested in knowing how much ROW is available. Now, what are the number of villages or towns within this corridor? This is important to note. So first thing we do is from which NH to which NH, what are the different kind of villages are there? Difficult to pronounce. There are so many villages here. Again, this is far less compared to any other part of the country, because again it is a border place and it's a desert. Now in any typical DPR, you will have to do all these investigations and studies. Okay. First thing is road inventory and condition survey. You might all know what inventory and condition survey, right? So within that you will have about 10 things to do. In inventory typically you will have to measure what is the width, what is the length, height of the embankment, all that inventory. The condition survey, you will know what is the kind of pavement condition, crust thicknesses, right? Distresses, all that. Then similarly you should know exactly same thing for the cross drainage structures. How many bridges are there, how many culverts are there, what are the condition of it, whether they are good, bad, failed, everything. Then get into the pavement part. In any road project, you must know the pavement is very important, right? You know the pavement, subgrade, GSB, WMM, bituminous layers, that's the pavement, and it costs. The entire project cost at least 50 to 60% of the money is only in the pavement. So pavement condition survey is very important. There you will have to do distresses, roughness, deflection survey, right, and crust thickness, everything. The fourth is important, topographic survey. You all know about topographic survey, right? Yeah, now we move advanced with LIDAR survey also, total station LIDAR. Then traffic surveys, your volume counts, your origin and destination studies, all comes from traffic surveys. Axial load survey. You know why we do axial load survey, right? Anybody? What for we do axial load survey?
Know the different spectrum of load that is coming on the
Exactly. So traffic load spectrum. You want to know traffic loading. That's why you do axial load survey. Then Winkelmann beam deflection survey, where again pavement deflection. Now we have moved. This is a 5 years old project, so we have moved everything from BBD to FWD, falling weight deflectometer. Then we also do DCPT. That is again a soil test, CBR. Take the pit and then do it's a direct pole penetration test that will give in situ strength of the soil. Then roughness, either that time we use pump integrator, now we are moving towards roughometer, right? Or like the rock does would have. Then trial pits are very important to know the pavement design. You know CBR should know the soil characteristics, soil strength, CBR. Then material testing. One is you have to test that soil, and also you should go for borrow areas, see where your soil and aggregates are available, whether those aggregates and soil are suitable for construction or not. You have to test all that. And another important survey which normally not be taught in the classrooms is environmental and social impact surveys. So when it comes to environmental, is forest lands, right? If the road is going through the forest land, there is a separate study has to be done on the impact of this project on the forest. So how many trees you are cutting, then there is a series of permissions required to take from the forest department. That is called environmental impact survey. Then similarly, social impact is when suppose there will be always some houses, some villages where you have to pass through and then you have to demolish those houses. So this is called social impact. So what will happen? Okay, how much compensation you have to give? Can we demolish this house, or if you cannot demolish, is there an alternative alignment to take? These are all part of the social impact. Then there many times we find temples. Okay, small temples. You have to shift the temples. Borewells will be there. Right, so that all is part of environmental and social impact. So it's a big area itself, and this is where most of the projects are get struck for years together without any permissions. Then last but one is geotechnical investigation, places where your structures, you are planning bridges, culverts, interchanges, flyovers. Then you are doing geotechnical investigation. The last one is revenue record collection and land acquisitions. Every road project involves land acquisitions. Right? Government will have certain ROW, and beyond that, when you are widening, you have to acquire that land. There is a procedure. The procedure that followed in National Highway Authority of India is different. The procedure that state government follows is different. Every state has their own method of land acquisition procedures. So, as part of civil engineers or highway engineers, we need to have people who can work with us on the land acquisition know-how. So, this is the studies, investigations required in any DPR of a road project. Okay, whether you do a small road or a big road, only the extent of depth of study will vary, but you have to do mandatorily all this. So now, when it comes to pavement, right? So, like I said, what is critical and important is making homogeneous sections. In any road project, you must first do a homogeneous sections based on your width of the carriageway or the condition of the carriageway, or from point A to point B, like town to town, village to village. That is very critical. Now, if you see here, we have the carriageway existing width of 3.75, 3.75, 5.5, 7, 7. You got 5 sections here, right? Now, there is a variation in roughness also. Like up to 56 kilometer, it is the unevenness is like this. Then you have 3 to 4, 1.5 again 2.5, 2.5 to 3.5, 1.1, 1.1, it varies. So these homogeneous sections, how do you make this absolutely left to highway engineers? Okay, based on our experience, we can make. There is no standard rule. So depending upon the outcome that we want to deliver, we can make these homogeneous sections. If you are smart enough doing a proper homogeneous section, you will save a lot of time in the entire study analysis. So this is just giving you a pictorial view of all the surface condition, right? And this is how the roughness varies from kilometer wise, maybe 0 to 1, 5 to 6. Okay, so this unevenness. You can see at some places this section is very badly shaped. These are all okay, normal. Again, you have a bad stretch here. So this picture gives us, what straight away we can say, okay, this portion is not good, so we can go for reconstruction. Now here we can do more analysis to see whether do we have an existing enough truss thicknesses, can we retain this carriage pavement or not. So based on this, again our expertise matters. Now again the deflections, right? Now again we plot these deflections kilometer wise for the entire length and see. If you have studied deflection values, you will know if the value is say 0.8, value is less, the condition is good. Or it can take load, the serviceability index is still good. If the value normally in us, in our practical, we keep a 0.8 as a parameter. Some people will say 1, anything greater than 1 is not good, but we keep around 0.8, anything more than 0.8, we will again go for subjective studies to see whether it can be placed or not. So 0.8, 1, you should remember always when it comes to deflection. Now, you have been all taught how to do a BBD survey? Huh? Remember this? What do you get in the BBD? Yeah. So what does the deflection give you? What is the outcome of the deflection study? What do you mean technically? So you get a value of say 1.2. So what does it mean?
It is a vegan.
Hmm?
It is a vegan method.
Okay. So what does that indicate? If the value is more, you all know. Come on, shout. What's the no? Sudarshan. This is not taught in restriction management.
Come out with the answers. What do you understand by a higher value of deflection? Yeah?
So, okay, very simple, right? It's a common sense. You apply a load, payment deflects, then the load goes away, payment retracts, right? This is what, right? So you measure what? How much it has recovered. So if the payment recovered well, your deflection value is less. So it means the payment is flexible, and it's a flexible payment. So it's good. If it's not retracted, you get more value. It means it lost its flexibility, right? Yes or no?
Yes.
This is all common sense. Don't see every time you don't get into a lot of engineering. It's a simple sense. If you understand this, you will never forget the subject. Okay? So you do all this. This you have studied again. Roughness, bump indicator. See? Gone to the road. Yes, no?
They have it in studies, but they are not done.
They are not done.
They are not
You should
yet done.
send all of
Yeah.
them.
No towing vehicle. We are not finding a towing vehicle. That's a problem.
Okay. This is called fifth wheel bump integrator. Okay. Now it's very difficult. Like Kavita said, towing vehicle, nobody takes all this. It takes a lot of time. So we all now move to roughometer, which is inbuilt in the vehicle, and then we just drive the vehicle. You get the reading. Everything electronic. You don't understand anything. You all get a reading, right? At least here you will see. Okay, it is bumping like this. That's why it's called bump integrator. So it actually gives you, how even the road is. Simple. Right? There is a measurement. The measurements varies from every country to country. We call International Roughness Index IRI now. And if the IRI value is more, it is more uneven. If it is less, it is good. And there is a value to where you can say it is good. Beyond that, it is not good or it is uneven. Right? Very simple. Now you do a pit at the edge of the carriageway to measure what is the thickness of the existing pavement layers. Now, in this case, there was a kind of sub-base layer of 150 to 200, base layer as all aggregates, and then a thin bituminous layer. That's all was in this road. It is not well constructed. Now, you all know CBR, right? Why we do CBR?
Bearing capacity
Yes, study CBR. Why do we do CBR?
To design a payment.
Design a payment. Based on the CBR, you know the graph, right? That is how you have to design a payment, and somebody has invented CBR, so you have to do this is a value, it gives a strength, and based on that only you can do a payment design. So you have to do mandatory CBR. You know how to do CBR and all, right? So here the subgrade CBR strengths are good compared to all other any other places. You got 30 to 15% is very good, even 80-90%. So anybody say what is type of soil SM is? I have forgotten. Anyone? Soil classification?
silty
You find out later, okay? This is how you do a test weight. Not very professional, but there's a kind of labels we got there. Actually, you have to cut at the edge so that your pavement layer has to be exposed. Okay, and there is an IRC code how to do 1 meter by 1.5 meter depth and all. The problem is again you do the pit and then you have to backfill also. So somehow we are little practical. You are able to see this. I mean, this is fairly okay. And then collect the sample for CBR test. And we will also have a slate written what is the chain age number and all. These are for records. So you have studied here, right? So we did every 2 kilometers. Do you know what frequency we should do CBR? Any idea? Yes, no? As such, there are no criteria like how frequent you have to test for CBR. But only thing as an engineers, we must test everywhere you see physically there is a change in soil at least color type. But otherwise, we normally say about 2 kilometers we take samples so that we don't want to miss any changes in the soil characteristics. Because you must always know if you are studying about 50 kilometers of road and every 2 kilometers you test CBR, every meter you do roughness survey, every 50 meters you do deflection study, you are not going to design road for every 50 meters. You are not going to change the crust thickness for every 100 meters or every kilometer. You always design for the weakest soil condition and the heaviest traffic loading, right? Weakest soil and heaviest traffic. So that's why the homogeneous sections plays very important. You take the homogeneous section of 20 kilometers, you will always design for the heaviest traffic and the weakest soil. So again, this is again a kilometer wise test. Then CBR whatever the chainage has been collected, sample. This is all the classification. You all know these terms, right? Liquid limit, plastic index, MDD, OMC. You are all aware, right? What is important in this? 2-3 parameters. MDD is important. Yes, OMC is not important. MDD is important, right? So CBR is important. Density is important. Plasticity index is important. 3 is always you remember in any soil when in the road projects. What is important is number 1, plasticity index. Okay, your soil has to be PA value of the numbers. Right, that is very critical. A density of more than 1.7. 1.7, more than 1.7. CBR value we can design for any 2, 3, 4, 5. Normally we prefer about 8 to 10% CBR. Now the new codes are asking us to design for 15% CBR also. So always remember 3 things, right? Plasticity index, your density, and CBR. Tomorrow when you attend interview, we'll be asking the same questions. You should prepare for all this. So again, what my team does is they go along the road and then find out where the quarries are available. Quarries are very important. Without soil available, without aggregates available, it's very difficult to construct the road, and also it requires for your costing, right? You should know if the soil is available close by, the cost will be less. If it is far off, the cost will be more. Unless otherwise we assess this properly, our entire project costing will go wrong. So you will have to do aggregates and earth, soil. Bring the samples, again test for acceptability. Again, if it is soil, you always say again whether CBR is there, density is there, and plasticity index. If it is aggregates, you know all the tests, like gradation and impact, flakiness, water absorption, right? Yeah. Okay, so very important then. Traffic studies. Why should we do traffic studies? Traffic is the basis for the road development, right? If there is no traffic, no road is required. So depending upon the volume of traffic, you will decide how many number of lanes are required. Traffic is less, 2 lanes. Traffic is more, 4 lane. Furthermore, 6 lanes, right? That is why you require volume studies. You also require axial load surveys for pavement design, right? Those are two purposes. And then you will also require intersection junctions for junction improvements. Only three purposes. Now you all know that we should do 7-day volume counts, right? You are all aware of it. ADT, AIDT. Yes, all taught. Okay. So as an engineer, tomorrow once you join a consultancy company or any organization, you will be, if you are asked to go do a DPR project, if you are assigned for a traffic responsibility, first thing what you do is you do a recce of the entire corridor. You will note down how many major junctions are there, where the traffic is coming and diverting or attracting. That is very critical. Number of junctions and how many number of towns are there. Towns is the place where the traffic gets attracted or diverted. So then you will plan, okay fine, if my point A to point B, from this town to this town, traffic is diverting a lot. So I'll have to do a mid-block volume count. I must know how much traffic is going from this point to this point, right? And then again within that junction you will have to do a turning moment survey. These two are very important. So as an engineer you will have to assess where I do. Where exactly you will do normally? You will do a place where between two junctions to get the volume counts. At the junction to get the traffic movement counts. So here we see we got these are the major junctions. This is where we did the survey, right? You know PCU factors? Yes? Yes, no, maybe? Say yes, I'll not talk. Say no, I'll talk about it.
ICM students would not be familiar with it because there are both the branch students here.
Okay.
Highway students would know about it.
Okay, so then they should not know also, not required, right? So you will anyway. Okay, passenger car units. This is the factors to convert all the vehicles into a single parameter, right? So these are the values, and from where you get these values are, if it is a rural highway from IRC, if it is urban, so it varies. You must know that TCU values varies from rural to urban. Yes, you are aware. Okay. Now, once you do traffic survey, you do 7 days, you average it out, right? You get a value. It is called as this one first. This is average daily traffic. Okay, because you are doing either 3 days or 7 days. You count all 7 days divided by 7. You get average daily traffic. Now this is based on the survey. Okay, this one section, second section, third section. You see the value? Very less. Border, only few vehicles used to go there. Now, you are seeing a little different word, another A is added. Right? So what you get from the volume count is only ADT, average daily traffic. But what you need is annual average daily traffic for the design. How do you get ADT from ADT? You will have to use seasonal variation factors, because you would have gone on the month of say now September, and you would have counted for 7 days. September might be heavy rainy season, and you would have counted only less vehicles. But that is not true. If you go in March, you will have more vehicles. So to counter that variations, you can do study in any month of the year. Then you go and collect all the seasonal variation factors. You have any idea how do you collect seasonal variation factors? Taught? Okay. So the simplest way is you go to the petrol bunk along the same road. You go and ask them, boss, give me what is your fuel sales every month for last 12 months. Okay, diesel and petrol. We collect all the details, about 3-4 months, whatever number of months are there. Then you study. The assumption is, if the more sales of fuel happens, it means more vehicles would have gone on the road. Simple simple. Based on that, you actually put the volume every month, January, February, March up to December. See how the variations are there. Okay, and then this month, if you have studied volume count on September, what is the sales in September, and compare with all other months with the sales. Today's month sale is 1, and then see the next month or next month, it is more than 1 or less than 1. You get 0.8, 0.9, 1.2, 1.2. Those are the parameters. So use those parameters, multiply with this ADT, you get AAT. Very simple. And you got IRC course to study and do. Tomorrow, whenever you are into traffic engineering working, you must know these parameters: AADT, seasonal variation factors. Okay. Once you get AADT of that year, are you going to design the road for this year's traffic? No. You are not designing for this year's traffic. You are designing for the future traffic, right? And if it is a national highway, we take about 20 years of traffic. The local roads, we take about 10 years. There are codes which says normally 10, 15, 20 years is a traffic. And traffic for the deciding the number of lanes is different. Traffic loading, pavement design is 2 different parameters. So for the pavement design, we take about 15 years for national highways. For local roads, about 10 years. So for the capacity augmentation, we take about 20 years, right? Now, you project the traffic for next at least 25 years, right? How do you project the traffic? Is that part of your syllabus? Yes? Okay. So I'm not getting into detail. There are different methods of traffic projections. Whatever method is being taught to you, you must know exactly how it is done, right? So it depends upon the population growth, it depends upon the vehicle growth, the past growth, it depends upon the GDP of the country, it depends upon the NSDP of the state. It's a different formulas are there. So I'm not going to get into that. It's a big area itself, but you must know that there are methods to forecast, and you must always do the right forecasting method. If you do any mistake in the forecasting, either you are going to over design the road or you are going to under design the road. So if you under design, what happens? Instead of 4-lane requirement, you will do 2-lane construction, and within no time, roads will become or Bangalore roads. Okay. So this is what we do. We project traffic, and for every 5 years we get these figures. And normally when we project, we do 3 scenarios, right? It is a pessimistic scenario, like very negative kind of thing. Growth will not happen, it may be about 4% growth. And we do optimistic scenario, or most likely. Optimistic is like, okay, there is super growth will happen, and like 8%, 10, 9%, and there is a normal growth. We always do 3 growths, and then we take the mid, right? That's what we do here. If you go to America, they do traffic projection for 100 years. They do traffic projection for 100 years. 25, 50, 100 years, and it must be there in the records. And that is why if you see in America, the roads built for 50 years back, even now, they are not over choked like our roads. So they take a lot of interest in this, and they don't compromise. I have traveled most of the roads in the US, but we don't do that. Why? Because there are too many reasons. Government thinks they don't have money. They think it is not possible to invest all the money now. There are various parameters. But when it comes to traffic projection, they do 100 years traffic. They assess, okay, what might happen even after 50 years, and they acquire all the land required for 50 years now itself. That is the way they function. What we do is absolutely opposite. We only do projection for 25 years, and again we design for 10, 15 years. And by the time we do the construction, complete the road, we will be back to the traffic where it should have been 10 years back. Here, in the traffic projection, one important aspect you must know is generated traffic. Any road that gets developed, you will see a lot of development happens. Factories, industries, township, the traffic generates. So as a traffic engineer, you must take that into consideration, right? And seasonal traffic. In our road, what happens? You saw is only 500, 600 vehicles per day traveling. But the army, you know, we visited army and we want to understand, what kind of traffic army. Then army said every year, 2 times in a year, they actually bring all their vehicles on the road and they do a drill. Right? For 1 week to 15 days, they do a drill. So we have to consider their vehicles also into our traffic projections. Without that, we would be actually not even requiring a single lane for the 500 traffic. So we took that traffic also and then added and said, okay, what kind of lane configuration is required? And even adding all that traffic, we found that it is only 2 lane required. 2 lane is required, right? And we did all these calculations, so I'll just skip all that. And based on that, we said, okay, from 2016, right, and 2034. What is the difference in number of years here? 14 plus 4, right? 18. So 2016 is a traffic survey year. 2 years is a construction period, right? And we always take 15 years from the opening up of the road, not from the day we do survey. Always remember, survey is done this year. You have to leave 2 or 3 years for the construction, and from that day, 15 years, right? That is how you get 234, 2034 here. Then this is the capacity. You know what is the capacity of a 2-lane road? 2-lane, 4-lane, single lane in area. You must be knowing. Okay, if you are not knowing, you have IRC codes in the library. Yeah? IRC 64, not down. After this class, you should go and read IRC 64. Right?
It's not available on Netflix. Library को होगा बड़ा.
Let them read. Okay, you must understand, what are the capacities, right? So the capacity of a 2-lane road is 15,000, no, 30,000. In the NHA manual, they have brought it down to 20,000. So go read yourself. Okay, go to ISC 64. Last 3 pages will be there. It would have given what is the capacity of a single lane road, 2-lane road, 4-lane road, and what is the code I showed for urban traffic? Remember?
64.
Huh? No, not 43. 64.
64 and
So
70.
go to the urban code also, read that also. You this is an assignment for you. Try to understand why there is a different capacities for urban roads and the rural roads. Okay. So in rural roads, the capacities are always per day. In the urban, it is per hour. Okay, this is the key difference. You understand why it is urban is per hour and rural is per year. Okay, you will know the subject well. Okay, you are studying level of services. Yes, no, maybe.
Yes.
Yes. I need a voice.
Yes or no?
Yes, sir.
Yes.
Be vocal.
Either you say yes, or you say no, or if you don't know, say maybe. Yes, no, maybe. What is that?
ICM student would say no.
Yeah, I agree. I mean, David will not study. Others, you are what? Are you engineering, right? So other discipline, what is your specialization? Highway technology. Yeah, you all studied? No. If you not studied, please, after this class, you should study about LOS, level of service. And level of service again varies from, it's called LOS A, B, C, D, E, F. Okay, go search internet, you will get a lot of studies. And IRC 64 also there is LOS, but not elaborate. Try to understand what is LOS. Go back, internet, sit for 1 hour, study on LOS. You will understand, why if you ever somebody says or you experienced why there is too much of traffic in our Bangalore roads, or maybe Bangalore Tumkur road, why so much of traffic, why these lanes are less, right? You should know what is LOS, level of service. Very big subject, probably the PhDs can be done, but one thing you should know, if the LOS value, if it is A, it is like ideal, B, is good. LO is C. Is D, E, F. It is a jam condition, right? In our rural highways, we always design for LOSC. That is as per IRC guidelines. If it is urban, we design for LOSB. So you yourself try to understand why you should design for LOSB and LOSC. What is the scenarios in B, C, and all. I'm not going to explain here. So basically, it shows your volume to capacity ratio conditions. Okay, so I'm going to now move away from the topic. This is important, right? You know, axial load survey, you get these parameters, you use for this payment design. And how do you do payment design? Huh?
As per IS 37.
So you need to arrive this, right? Design traffic in terms of MSA, million standard axles, right? And you know design MSA and you know the CBR and you got IRC 37,
28.
go to the relevant chart, go to the table, you get the payment price, right? You all clear? Okay, so you know how to calculate this design MSA. Commercial vehicles, multiplied by VDFs, 365 formula, right? Yeah. Okay, these are all some of the photos. We did all the studies, axial load survey, traffic, is a turning moment, counts. I told you petrol bunk, right? Collecting data from the petrol bunk. Okay. Now you did all the studies, surveys, investigations you are done. You are fairly now clear that you know what is happening in this road. Now you have to design that, right? So where do you start designing? So you will have certain design standards, right? If you are designing a national highway, you want design standards for national highways. If you are doing a design of an urban road, you will have certain design standards for urban road. So you will have to first get into the relevant code and extract all the parameters. See, you don't have to remember all these things in your mind, but you must know which code you should refer. Okay. If I am doing my traffic analysis, which code I should refer? You should know IRC 64. If you are doing payment design, you must know it is IRC 37. Or if it is a overlay, IRC 81, right? 81 or 82? 81. And if it is a rigid payment design, IRC 50? Okay.
58.
So, 58. So, you must know these codes. Then you can always go back to the codes and get the relevant sections. So here, this is a code called IRC SP 73 2015. You must study this code, okay, out of your interest of the subject, not for the exams. I don't think whatever I'm talking now is never going to be the exam, but it is for you to know about the subject and it's going to help in the future. Now, IRC SP 73 is a two-laning manual from the Ministry of Road Transport Highways. We have to design all the two lanes based on this manual only. One single manual to give all the information how to design, traffic, payment, everything. 73. And the first version, again I think second version, 1980. Okay. So it shows what is your terrain conditions, how do you. Okay. Now. Fine. You go to the manual and you have geometry design. You know what designs you should do. So you will design the alignment, you should do the profile design, you get the cross section designs, everything. And based on the traffic volume, if you require a flyover at the junction, there are values. If the projected traffic in a junction is crossing 10,000 PCUs, it warrants, it's called warrants. It warrants for a interchange. If it is not, you don't have to do. Then there is a typical junction designs are there. NHI design manuals, get into that. You know how to design a 4-lane junction, 2-lane, 3-leg junction, 4-leg junction. It's all part of the design, okay? So it's a big subject itself, not going to cover this short period. So once you do all that, right, you will prepare a summary of all the proposals for the road. What is that? So we are based on the traffic, it is being concluded that it's going to be only 2-lane road, right? And there are curves which is to be improved. Okay, suppose what is the design speed of national highways and state highways? 80 to 100. If there is a curve of say 180 meter radius, so it doesn't meet the speed requirements. You know what is the minimum radius required for a 100 km speed? 360 meters for a 100 meters. Sorry, 100 km of speed, 360 meters of curve length is required. So what we do, existing we do topographic survey, take that drawing into the computer, you got design softwares, or you can use AutoCAD and measure it. Then you start designing the alignment. You fit a 360 minimum length of the curve. If it is following the existing road, it is good. If it is not, you have to realign it. So this is the length. How many kilometers of total length is going to be realigned in this 200 kilometers? Okay, this is 6 kilometers. Now, wherever there is a villages, towns, we have to design mandatorily a 4-lane road. So how much of that length is again 4-lane? This was the airstrip. I told you that we designed an airstrip also on this road. So it was mandated to design an airstrip. On this width is 23 meters for a length of 3 kilometers. So total around 97.1. In that again, how many minor bridges are there? How many culverts, box culverts, slab culverts? So what is CUP? Cattle underpasses, major, minor junction, villages, towns, number of bus bays, where the bus stops are required, how many bus bays are to given, and truck laybys. If the length of the project is more than 100 kilometers, we have to mandatorily design rest areas for trucks. This is called truck laybys, and if you are going to implement this on a toll, you need toll plazas, right? And plus passenger amenities, these restaurants, repair shops and all this we have to plan. If you find a road where all of these are not planned, you just presume that the consultant who did the design is wrong. Simple. That is why you ended up a wrong project. Because only if you do proper design of all these components, the same thing will go for construction. If you don't do, it will not do. So that is why the key of any good development of the road lies in the DPR consultants. You guys, okay? Maybe next year you will be part of this. Okay, next comes important parameter is we did all the designs and all. The culmination of the entire DPR study is what? 3 things. One is the plans, all the plans, how the road should be constructed, what your typical cross section, what is the width of the carriageway, median, all those previous slide components and all. Then second is it has to be brought into quantities, unit rates, costing, very critical. And then the contract document. 3 important things. The drawings are important to the contractor so that he knows what to do, how to do. So typically what we do, how much our length of the road is, whether it is 10 kilometers or 100 kilometers, we design this into a TCS, typical cross sections. And these typical cross sections, if you go back here, see your two lane can be a typical one cross section. But depending upon the terrain, it can vary. There are places where the embankment is 0, your cross section is different. There may be places where you got high embankment, then your cross section is different. So you will have to identify from which chainage to which chainage a typical cross section is applicable. Okay, that is very critical. Similarly, it's at 4-lane at urban areas. Okay, so if you see, we have made here TCS 1, 2, 3, 4, 5, 6, right? And then we did another 7 for realignment of 4-lane, and these are all the 2 options video. I'll explain this later. Now you see how the typical cross sections will look like, right? This is a 2-lane cross section. You have to have mandatorily 7 meter carriageway, 1.5 meter paved shoulder, 2 meter earthen shoulder. All together is, what is the width? 14 meters. 14 meters is what you see on the top. Depending upon the height of embankment or cutting, the overall width of tow line will vary. Now here in this case, you see this embankment varies. What is the slope here? 1 vertical to 2 horizontal, 1:2. So it means what? If there is a 1 meter height of embankment, what is the width of this embankment? 2 meters. If the height is 2 meters, 4 meters, right? Then you will have one earthen drain, then this is where your ROW comes. So how do you fix the ROW now? If there is a 50 kilometers of length, you take the highest embankment location, right? All others are constant, right? This is constant, only this varies. So take the highest embankment location, if it is 3 meters, 3 into 2, 6, this side, 6 this side. Add all, you get one value. So based on that, you fix your ROW. So the manual says a minimum of ROW of 30 meters or 45 meters or 60 meters. In case, if your requirement of this goes beyond the 30 meters or 40 meters, then what you do? You put a restriction here. By how? Retaining wall. You put a retaining wall, bring the slopes into 1:1 vertical and reduce the width, right? Now, this is a TCS 01, TCS 02. What is the difference between this and this? Can somebody tell?
Clarification of it.
Subgrades.
Shout. Exactly, you said right. Here it is existing road, we are utilizing it, right? We have written here, scarification of existing surface, and we are building a GSB layer on top of it. And rest everything remains same. What we are doing here is, you are not studied here.
Yeah.
It is a realignment section, where there is no existing road. So, this is a difference, right?
Ratnakar, if you can highlight on the concentric widening one, which is on both sides and sometimes only on the one side. Why that happens?
I think there's a lot of
Symmetric, asymmetric.
dispute on it. See, when you have 45-meter ROW, some code says you must do widening on only one side. I mean, use the bring your ROW of left and then only construct your new road one side and leave all the other side for the future widening. But it is not working. Why it is not working? Practically, if you do on one side, protecting ROW on the other side is very different. Giving access to the other properties and all is different. So it is only in theory. Practically, we are not doing anywhere. We are always going on the concentric widening, right? So when I started my career 20 years back, we used to do a lot of option analysis. What if I fix the center line on the edge of the carriageway? Okay, so eccentric left, eccentric right. We did a lot of projects like that. Implementation is a big headache. So it's still academic interest only. So right now you don't worry about it. Okay, now again this all remains same, right? What is the difference here? Those cross sections were in embankment, filling. This is in
Cutting.
cutting. Your existing ground is here. Okay, what is the difference if you are in a cutting? This drain becomes, instead of unlined, this becomes a line drain, concrete drain. Rest everything remains same, right? Now again, TCS 04. What is happening here? So I told you, we got 30-meter ROW. If the height of embankment is more, this embankment line is going beyond your ROW. So you are putting a retaining wall. It's only difference. Rest all remains same. So identifying these structures, exact changes is in the hands of the design engineer. When you design in a road software, you will run the cross section, you will get the tow lines. Okay, you will have to mark exactly. This is where the engineering happens. You miss out here, the end product will have variations. Now this is again 4-lane, right? 4-lane with a box drive. Now what is happening here? This TCS 06, airstrip. So I think it's not visible from there. It is 23 meters wide. Then we gave the separate service roads. Why? Because if the plane is landing there and some vehicles are also coming, they need a space and emergency ambulance. And there's a guidelines. There's a separate guidelines for runway designs. I think some of you might even get into runway designs also. We do that also. So there's separate manuals and guidelines for runway designs. It is from the Airport Authority of India. Another organization is there. So there's a whole method itself is different. How do you design? Mostly on American standards. We still follow that. Like roads, we have IRC standards. There it's called FAA, Federal Aviation Authority of America. So we follow most of their guidelines, and there's a different thickness. All these thicknesses will vary. We call 250 mm WMM, they give 500 mm WMM. So thickness, everything varies depending upon the. Again, there it's very simple. Here we design, I said, heavy traffic loading and weak soil. There the design is for the heaviest aeroplane. Like Boeing company has their biggest aeroplane, you design for it. So this is again 4-lane road with a 60-meter ROW. Okay, fine. Now similarly, while you all will be working on highway, pavement and all, you will have your colleagues working on the structures, right? Those who are on MTech structures, or maybe civil, or maybe sometimes you also will work. It's not a rocket science, but you will have to give all the widths and all for them. Okay, I want a bridge of this much top width, culvert of this, and we only as highway engineers will only tell what is the length of the bridge also. We only tell what kind of interchange is required, what kind of flyover is required. Structural engineer will only design for what we want to be designed there. Okay, so the pavement, we have recommended this pavement like 40 BC, 80 dBm, 250 WMM, 200 GSB, and subgrade of 500. Any flexible pavement design, it's not going to vary much, except for your BC and dBm, all this will remain same, right? So whether it is 50 MSA, 150 MSA, 20 MSA, only these parameters will vary. This all will remain same, except the cases where you have a very weak soil, like black bottom soil, marshy soil. Rest everything remains same. There where the toll plaza comes, where the not runway, only toll plazas we design PQC, pavement quality concretes, and 260 mm, DLC, GSB, and then CBR. Okay, so environment height is okay. For you to do quantification, right, estimation, after this somebody will work on the quantities, right? So you as a design engineer have to give him chainage wise embankment heights. Without that he cannot calculate quantities, right? So what is the height of embankment? Based on that, what is the filling is coming, what is the cutting is coming. So you will have to generate this from the software. That is your primary job. Okay, the geometric improvements I'll see here. I will so skip this. We are talking about curve improvements, right? So if you see here, the existing road is this, going like this all the way, like this. So you got one curve here like this, one curve is like this. What you have designed, combining all of them into one single curve. Similarly, if you see here, the road is coming like this, then taking a left turn, again taking a right turn and going like this. So what we have done is, we have actually realigned this into a super curve, right? And this is, as highway design engineers, is your primary job to make sure you do a proper geometric design. And you see all these accidents happen. Recently, Cyrus mystery died. You saw in the paper and all, blaming design engineers. Partly we are all responsible for that. Unless we are carefully designing all this, we'll end up having accidents. If you design this for 65 km speed and the vehicle comes at 100 km per hour, then vehicle will be overthrown. Now, I told you we'll have to design a rest area, right? Our road is like this. We're taking a small road and all that. We're improving this curve again. So then there is a place where if you see this red line, this is the existing road. It's coming all the way like this, taking a complete right turn, again going back like this. Now we'll have to realign this. So again, everybody wants options. Okay, what is the guarantee that whatever we have done is correct? So we'll have to work out different options. Do option 1, option 2, option 3, get the optimal length. In any realignment, what is optimal is the least length is the optimal. Least length satisfying all the design requirements. So in case here, what my design team has done, no, they thought, okay, why not we take like straight like this and take all the way like this and do it. You know, this is a railway track also here. Okay, this is a railway track. That is why it's critical. The vehicle used to come here all the way, cross LC, there's a village here and then go like. And what we also did is, we just realigned like this. So this alignment was preferred alignment. So as a consultants, we design all this and we also recommend what is the preferred option. Okay, so this is again structural recommendation. How many has to be reconstructed? 0. New construction, these many. Retained anything? No, all are new construction. Here, reconstruction only 1. New construction retained, 7 or retained because they are in good condition. All this is very critical for you to bring the proper cost estimation. If you mess up anything here, you do a wrong cost estimation, will have impact on the construction, then you see variations. 100 crores will become 150 crores. Then everyone will be taken task and start blaming will happen. So these are proposals for intersections. I'll skip. We did design for helipad. Along with runway, we were also asked to design, I think, 4 helipads off the road. Okay, this is a landing strip. Okay, fine. Now, the critical point is, okay, you design everything, you run the ROW, you have to collect existing ROW from the government department, superimpose on it, and then you have to calculate how much additional land has to be calculated. Okay, we'll have to mark. So our job as a design engineer's job is to mark those lines and give it to it land acquisition person, so that he will start working on the record, land record. So it is our job. If we again do a mistake here, that we did a wrong line or we did calculate the proper width, we'll end up in wrong land acquisition, project will get struck. In this project, we had experience. We messed up a little bit in ROB, railway overbridge location, and it took about 8 months delay in land acquisition, and we got 2 notices also. It's not actually our mistake. Land people did not give, but end of the day, they always tell, okay, you did a mistake. And they withheld our payment for 6 months and then they released my payment. So you are very, very critical in these issues. So you'll have to calculate the extent of the land, how much cost, is all part of your cost. Then another critical in all these road projects is utilities. Existing road will have some water supply lines, electricity cables, telephone lines, village, rural schemes, some pipes and all is there. So we have to assess existing utilities properly along the road. Then we have to do a costing of that for the replacement. If you don't do that replacement cost, again project gets delayed. Whatever that cost, if you don't consider in the estimate, then department will have a problem. They will have to take some more approvals, that gets delayed. And most of projects in the country, we are facing utility issues. And it takes a lot of time. How do you identify some pipe is going below the road? You will have to do a GPR survey, right? So GPR survey is the latest technology. Go back to 10 years back, we never had any GPR. So we'll have to go ask the local village people, asking them, sorry, pipeline hogta idya, cable hogta idya. So based on that information, so it all depends on how accurate a person goes and does the survey. So now you got a GPR, at least you run the GPR and you get all the pipelines below. Overhead, at least you can see. So here, what was it? OFC, hand pumps, open runs, tube wells, telephone poles, electric poles, transformers. These are the major utilities. Then I told you forest is very, very vital. We'll have to identify where exactly the forests are there. And the funny thing is, when you travel in this road, everything is desert. At least here you travel in our road, forest means you will see a lot of plants. Forest and section in Mara Kansunder. Actually it's a forest. There is a board also. There, it's all desert. So you will have to collect the maps, right? Maps, and then check, superimpose and check and find out what are all the, we found that there are 5 forests in this 200 kilometers. So these are different name of the forest and then different trees. And in Rajasthan, the problem is because it's a desert, they don't want any trees to be cut. Unlike here, we can cut thousands of trees. So they are very clear. You have to identify all these type of trees, what is the type of girth, everything, take permissions and cut. There are some deers, special deers in that desert. So deers need shade. Okay, so that's very critical. So as part of environmental impact assessment, we found we should not cut, so we need a lot of real elements. Again, it depends on who does that study of the road. We could easily recommend for cutting and then everything is cut, but we can always save those trees. Okay, so I told you the forest lands. Okay, there's no forest up to 42 kilometers. Then only for 1.35 kilometers you got a forest, and there's nowhere this forest. And it's difficult to identify this. There are no trees, but it is on the records. EMP, I'll skip all this.
Yeah.
So now project cost, right? You did a DPR, right? Your job is done. As an highway engineer or a traffic engineer, all your job is done. But what requires important is the project costing. Now, as a designer, you must also know how to do estimation and costing. That is a critical knowledge you must have. In our companies, what happens, we always have separate professionals. Geometric design is done by somebody, payment design is done by somebody, traffic is done by somebody, estimation will be done by somebody. Okay, so because it's a huge work, so everyone is specialized for it. But I always recommend all my staff, my employees, that you must know everything. Then only you become a good professional civil engineer. If you know only one subject, yes, you must get specialized in one area. Like you must specialize in payment design, so that after 5 years, 10 years, any question asked to you on the payment design, you should be able to answer. At the same time, you should know geometry design. You must have knowledge on estimation. You must have knowledge on everything. Okay, that is very critical. You always learn that, and you cannot be master of all. At the same time, you should not be jack of all, right? So pick one area of your specialization always. You are interested in geometry design, you pick that as your specialization. Payment, pick as payment. You want to get in traffic transportation, pick as that. That is your specialization major area. But you must all knowing and working in other areas. That will help you in building your career. So, if you see here, 197 kilometers costed 855 crores for flexible payment, 1002 crores for rigid payment. And as part of this, we must always do this value analysis. We have to always recommend the least cost and the good best specifications. So whichever is cheaper over a life cycle is always recommended. Now, this is cheaper, right? 855 crores, 5.23 crores per kilometer. This is little expensive. But if you do a life cycle cost analysis for next 20 years, probably this will become cheaper. So recommendation is our job. Accepting and choosing is the client's prerogative. So second is you have to do costing depending upon the packages. See, no project can be awarded for entire 197 kilometers to one contractor, one package. You have to optimally come out with maybe about 300, 400 crores or 500 crores. This we have to discuss with the client before itself and say, okay, what is the package size you are going to do? Is that based on the length or based on the value? So here we decided we must have 3 packages, and for each package we did all the calculations, like 335, 207, 289, and similarly 390, almost closer to that. And this packaging again it should be again point A to point B, one town to another town or one junction to another junction. So, in a typical road estimation, you will see subheadings like this, right? We always call bill numbers, bill number 1, 2, 3, 4, 5, 6. So the first thing what we do is site clearance, right? Common sense, right? You go to a existing road, you do clear all the cut the trees, clear everything, dismantling any unwanted things, you dismantle all that. That is always bill number one. All the earthwork, cutting, filling, including subgrade, up to subgrade level, is called as earthwork bill. Then your GSB, WMM, both main carriageway, service road, everywhere is always bill number 3. And on top of it, bituminous course is bill number 4. Then all your culverts is bill number 5. Major and minor bridges are bill number 6. All the drains, drainage, retaining walls, embankment, pitching will come under bill number 7. All the traffic lane marking, signboards, all that will come under separate bill. And anything you do on the bus bay, truck lay-by, some projects they may not be there, will be bill number 9. And anything else is bill number 10. Now, in a typical project, you will have till year, bill number 8. Whether it is a urban road, rural road, MDR, NH, you will have all this. Only in national highways you will see these bills. What is this? Highway patrolling operation. You have seen in highways, patrol vehicles. You know HTMS, highway traffic management systems. If you go on national highways, you will see some telephones, cameras, and variable signboards, accident prone zone. All this comes under HTMS. It is mandatory in the national highways, not in all state roads. So this you have to separately estimate for this. Then when there is a toll collection, toll plaza, major and minor junctions, if there is railway or flyovers here, and in our special case we got helipads also, right? So if you see, is there a percentage of the cost here? So normally, I think this road here, we always put one column here and compare what is this cost with respect to this total cost. Okay, percentage. If you see here, can you quickly somebody add these 3? Bill number, okay, add 1, 2, 3, 4 and divide with this or this value. Okay, somebody else does do this, divide this 39 divided by 39 plus 7.28 with this. 61%. I told you the payment cost is around 50 to 60%. This is where the major cost goes. This is where you have to do a lot of value engineering also. Can I reduce this? Can I do something in bituminous courses? Instead of DBM, can I do different kind of bitumen? Right? What is this traffic cost again? 39 plus 7. Here we 855. 47 by 8, we got 5%.
5%. 5.3.
5%. So 5% of the cost only for traffic, signboards, lane marking. Typically, if you go to America, Europe, they will keep about 10% of the cost for traffic safety. So compared to that, we are still very, very less. So it directly shows why we have more accidents here and why we have less accidents there. So they spend a lot of money on road safety, right? Once, see, you got this cost is the actual construction cost, right? But that is not what the project cost. To that cost, there are various other costs has to be added. Now, we did in 2015-16. The tendering might get delayed. So you need to have a little bit of contingencies for that. Then you need a consultant, like if we are a consultant, we also do supervision. Okay, there is a consultant to record to project management. There is a fees, 2% of the total project cost is for PMC. The government takes an administrative charge, about 1%. These are norms. Then government also spends about 1% from the government side for the quality control. Then nowadays it's mandatory for road safety audit. Okay, another 0.5% or 0.5%. Now, do you think that today's cost remains same after 1 year? After 1 year, it's called escalation. So for every year, we keep about 2.5%. 2 years is about 5%. Then once the road is constructed, the contractor has to maintain this road for 4 years, and we pay about 5% for that 4 years. That cost has to be added. If you add all this cost, it becomes 1042 crores from 855 crores. Then the utility relocation. At that point of time, normally what happens, we would have not got the complete picture of utilities, so we put some value, like here 20 crores. Then this cost, you are acquiring properties, resettlement, another 37. So the cost has become 1099 crores. So civil work cost is only 5.2 crores per kilometer. This total project cost is 5.52. So you would have heard, what is the cost of Bangalore Mysore Highway? Anybody read in the paper? It's about 7,000 crores. Right? So these are the costs all to be added into it. So it's not just what we calculated here, 855 crores. 855 has become 1,100 crores. And on top of it, when it's go for tendering, the contractor might think, okay, what we have estimated is not correct. The aggregates are not very close by. Your unit rate is very less. My labor rates have gone up. So you will maybe probably quote 10% more. So this becomes from 1,100 to 1,200 crores. And if they quote like that, then the NHA will ask us again. So why contractors quoted more? So you need to give the justification on it. So this all happens in the project. Now, similarly, whatever we did for flexible payment, we have to do the same for rigid payment and give them the choice to choose. So for the rigid payment here, it becomes about 1,293, about 200 crores more. So we did a comparison, okay. So what is the total cost bill-wise for flexible and rigid? 855,000 becomes 1,099, 1,278. And based on this, the department, there's an high-level meeting happens in NHA at the secretary level. We'll have to present this. This presentation is exactly what we did there. I'm showing here. So there, a lot of interactions happens. And then finally, we agree. Okay, we'll go for this or this, and then that is how the decision will be made.
So it was a comparison between the whole project being rigid or flexible.
Flexible.
It's not some regions being flexible
No,
and rigid.
no, that is any mandatory. Are there toll plaza you have to do concrete payment? Maybe all Buckley is concrete, but otherwise
It was a comparison for
comparison. So what is the right thing?
So what was actually
Here went for flexible. The government did not want to spend more money. They thought traffic is less, so we don't want to spend. So
even the runway part was flexible.
yeah, it's a flexible.
Even helipads are flexible.
So you heard something on economic analysis. Is that part of
It's
syllabus?
a part of syllabus.
Yes. Yes, sir. For both the streams. Huh?
ICM studied it in a different way.
Okay.
Maybe somewhere in.
Economic analysis basically gives whether whatever money you are going to invest is really bringing any value. It's called economic internal rate of return, right? Now you know all bank interest rates, right? Savings account, what is the interest rate in savings account? 6%. Okay, around 6%. Now suppose you want to keep 1 lakh rupees in the account, what you will do? Yeah, so you will inquire about 4 banks, right? And you will see who gives more interest, you will go and deposit there, right? So it's exactly what happens here. Suppose government wants to, we said it costs around 1,100 crores. Now government will have to decide, if I spend 1,100 crores here, what do I get back? Right, that is called economic analysis. In the practical sense, any project having an internal rate of return more than 12% is called as a good investment. Okay, government will decide, yes, we can invest, otherwise will not invest here. And most of this is important if the project is funded by external aided like World Bank or ADB or Asian banks. Now, for them it is very mandatory because as a country, or suppose Karnataka will request World Bank that I want to develop these two projects, maybe like Bangalore, Tuмкuru, Shimoga, or some say Hubli, Dharwad, Harvey. Two projects I want to develop, please fund. Now bank will choose why I should fund only these two projects. Then they will ask, okay, you give me reasons why it should be funded. Then we will have to give all these analysis and tell, look, I'm getting more economic returns here. The bank will always think the government is doing a wasteful expenditure or not. That is where all this EAR came. Now we are doing for NHA also is mandatory. Unless this value is more than 12%, they will not accept. Okay. Why? Because government will have 100 projects to fund. This is Rajasthan. Similarly, in Karnataka, 4 projects should have gone to government. Every state would have submitted 4 projects to the government. Now, government will have some budget and more projects. Now, which projects to be chosen based on this? So, whichever project give more EIR, they will give first preference. Okay, fine, let us go and construct. Now, in the economic analysis, what we do is we take an analysis of 25 years. We normally we run a tool called HDM4 software, or you can do a simple spreadsheet analysis also. HDM4 is mandated nowadays. We calculate all the costs. You saw the cost, right? There, construction cost, and then total contingency, utility shifting. If suppose 1,000 crores have to be bought from the bank, what is the interest rate? All that you add, finally you get what is the total project cost for each package one. 408, 2, 3, 4. You input this cost into the model. This is my project cost, and this is the traffic that plays in this stretch of the road. So best case scenario is you are not doing anything, you are leaving as it is existing single lane carriageway. Your proposed scenario is I am going to develop into a beautiful 2-lane road. And then cost of this base, do nothing is 0. You are not doing anything and you are not investing anything. And here you are doing this a proper 2-lane road and you are investing 1,000 crores. And the model will be run. So what are the costs there? Emissions, right? Delays, vehicle operation costs. So it's basically, if suppose the road is narrow and congested, design speed is less, so you spend more fuel, more travel time. The road is well developed, speed is more, you have less travel time and less fuel consumption. Based on that calculation, you get these values. So economic analysis itself is a subject. Okay, so basically you must know economic analysis, the costs are your emissions, vehicle operation, the fuel costs and travel times. Benefits are opposite to that, savings, all the savings. So here what we do a base case analysis as it is. And we do an option, sensitivity analysis 1 is, suppose my cost assumed is increases by 15%. What will happen to the results? Suppose in other case, my cost remains same, but my benefits, whatever I'm assuming the benefits that my reduction will happen less. Suppose it's reduced by 15%. What happens here? The last scenario is my cost also goes up, but my benefits comes down. It's a deadly combination. What is going to happen? If you see here, from 14.67%, the worst case is 11.54. Right? This is what normally we take, whether it's close to 12% or above 12%. Maybe I can take once HDM4 itself for about 2 hours. Okay, probably I'll come back in the next semester. Okay, like we did economic analysis, there is another thing called financial analysis. You know the difference between economic and financial analysis? Yes? No? Yes? Okay. Economic analysis is basically the indirect benefits, right? You invest money on this road, you get savings only in travel time, savings in fuel costs and all. Financial analysis is basically, if as an investor, as a contractor, if I'm going to invest 1,000 crores on a toll project, do I get back my money? This is a financial, this is a real finance. Okay, put the money, take the money, like your savings account FD. Okay, I'm going to put my 1 lakh here, I get 6.6%. So per year I'll get what? 6,600 rupees or 6.6%, right? Now then there's the income tax, 30%. Deduct that. So how much I'm getting? Simple calculation is financial analysis. What we do in all these NHI projects is, first we do analysis for toll. We'll ask, suppose a contractor comes and he will only put all the money, like 1,200 crores he will invest. And he will start collecting toll for himself. Is it viable if he does like that? Okay, I put 1,200 crores and I keep collecting the toll. If I collect for next 20 years, will I get back my money? This is a simple outcome of this toll analysis. But with the kind of traffic you saw, 500 vehicles per day, it is impossible to get back the money. In that case, what we should do, we go for annuity analysis. What is annuity? Here, the contractor puts all the money and collects toll. Whereas here, what happens? He will put all his money, but he is not going to collect that toll. Government will pay him a fixed returns every 6 months. You put 1,200 crores now, construct, maintain for 10 years. Government will say, I'll give you every 6 months, say 100 crores to you for next 10 years. That is called annuity. Why? Because here the risk is on the traffic. Traffic is less, nobody will invest. Here they will invest because he is getting a fixed returns, right? So we do analysis of toll, we also do analysis of annuity, and there's a lot of assumptions. I think I don't want you to know this. You should know that there is a financial analysis. Based on this, we always recommend. There are projects where we recommend absolutely the toll works. Projects where it doesn't work toll, it works only in annuity. And government will decide whether it will go on this or this based on the analysis outcome. In this case, neither the government did for toll, neither did government go on an annuity, it went for EPC mode, like item rate contract. Why? Because DCC equity IRRs, we all got negatives, negative, because traffic is very less. Even government giving 40% viability gap funding also is negative. Project NPV is all minus. Okay. After doing all this, we have to do a final conclusions. Okay. That based on that conclusions, everybody will decide what is to be done in the project. So here we mention all this. What is the proposed length? What is the ROW? Where the realignment, landing strip, helipads, toll plazas, major junctions, structures, retaining walls, structural wise, total land required, flexible analysis done, rigid payment, estimated cost. So, see, you saw your recommendation, just read this sentence. Done? What is that? Did somebody just say what you understood? So one of the reasons we felt was that Rajasthan and that road got temperatures rose by 50-55%. And placing concrete at that temperature, we get a lot of cracks. So we didn't want to take that risk. So we recommended go for flexible payment. Okay, but we are not a final authority. We, as a consultant, we can only recommend. Finally, NHA has to take the call. That's it. So these are some of the studies over a big survey. SPT or good investigation. I saw forest, right? This is a forest.
This is the first. Green.
Border roads organization, yeah. Utilities. Very tough working there. Any thing you want to know, whatever I spoke for last 1.5 hours?
Sir, on the comparison between flexible and rigid payment, the vehicle operation cost, how can you just compare? Sir?
If you run HDM4 model, there are inbuilt equations built for both the flexible and rigid payments, and vehicle operation costs vary on both. Okay, so it's a big subject itself. Probably there's a plain equation. We got 101 equations. Probably it's a very curious. You have HDM4 here.
No, we could not procure it. We are still in the process of, finally procuring it. There were so many pros and cons.
Okay.
So we wanted to know whether it's only educational or we'll have to do something. Then finally we have decided to go in for the educational.
No, at
Purely
least
educational.
you can download those documents. Go to website, type for HDM4, goes to World Bank and University of Birmingham. There's a portal. There's a literature available. You can download and read. Academic interest.
Yes, yes.
Sir, and also for runways, how the economical analysis has been doing?
No, the runway we didn't do any economic analysis. We did it as a part of the highway. Because runway is an optional.
That was design separately.
It's part of this project only. Payment design is different.
A little light on the tendering process, how it happens, maybe even in Karnataka side also.
Before that, I have questions.
Yeah. So if you see, visible there. Basically, these are in a part of DPR. We'll have to submit almost 11 documents like this. So one of the key things you all have to learn is how to write reports also. Okay, your success of your career, becoming a good professional also depends on how good you are in communication, how well you articulate, how good you write, whatever you design. Okay, that's very critical. You have to learn that skill. See, whatever now the slides I said, all the team we work, end of the day, it all put it into a document. The document is what somebody will read, right? Like for example, if you see this project, this is a detailed report part, right? So it has what 372 pages of write-up for everything, whatever I spoke. Everything has to be detailed here. Every component, everything has to be written here. And it comes with, you see, main report. Then you got volume 2. Volume 1 is main report. Volume 2 is highway design report, structural design report. Then there is annexures to that. All the softwares we run. Everything has to be submitted. Then volume 3 is all the soil investigation report. Volume 4 is environmental impact assessment report. 5 is technical specifications of all the components. Then volume 6 your rate analysis, you got cost analysis. Volume 7 is cost estimates. 8 is bill of quantities. Then the drawings, both highway and structures. Then the contract agreement, civil works contract agreement. Then the project clearances, what are the clearances required. Everything culminates into the DPR, right? So once you do all the designs, we do a parallel project preparation, report writing. So it takes about a month or 2 to compile everything and print it and submit. We have to submit about 7 sets of all these documents. This will be like this much of big boxes will go.
I think it's mandatory to put it in the public domain also, no, for all projects. No?
Yeah, it is there. If you can go to NHA website and all, you will see.
It will be there.
Yeah. This is typically the drawings volume. Just want to show you the drawings. So you can get into any NHA portal, you can download PDFs of all our documents are public. These are your plan profiles will be there. Every detailing will be there in the drawings.
I just wanted to ask, Elanka, the flyover, I think, na, PMC is with.
Yeah, yeah, I can. Okay, I'll just quickly explain all the typical contract document, right? So this is another project we just completed Yelahanka. You have seen Yelahanka, all of you? RMZ Mall, Police Station Junction. Huh? No, you not seen Yelahanka.
I have to take them to my house then.
Okay, if you go from Nepal to airport, this is airport road, like this here. There's one small ROB getting to Yelahanka. This is Yelahanka circle where you got RMZ, Orion.
Gallery.
Huh?
Galleria,
Galleria, RMZ Galleria. This is a mall. So we have designed a flyover starting from here, all the way go like this, take left turn, go all the way to the Dubalapur road, then down here with one down ramp, another up ramp, and down ramp here. It's a big, about 2 kilometers long flyover. Okay. It's a 4-lane flyover. Okay. So what is the cost of this project? 175 crores is the project cost. What it contains, viaduct means all the flyover you see, top portion is called viaduct. Then ramps, retaining walls, upgrade road, traffic, lightings, landscaping, all is 149 crores. Utility shifting, 4.5 crores. DPR and PMC cost is 2.24 crores. GST, all is 175 crores. Now, when you put it for tender, okay, the cost is always this cost, right? All this is part of government department has to take care. So for this cost, we are going to float for a tender. So let us see how a typical tender document will look like for this project. So every state, like Karnataka, there is a standard bid documents. There is nothing you and me have to do anything there. So they will have a standard bid documents for projects of a certain cost, like costing more than in Karnataka, projects costing more than 10 crores is in single document. No, you don't have to change anything there. Only you have to add project details or something. Otherwise, document is all same. If you go to central government, NHA, they have again their standard document, right? So none of us as engineers will work on the conditions of the contract. We only have to know the contract conditions as a knowledge. Now, for example, here, this we are tendered on a turnkey lump sum fixed price no variation contract. What does it mean? There are different modes of tendering. Okay, you might have heard EPC contract. You might have heard annuity contract, you might have heard item rate contract, right? The different methods. These are all item rate contracts. But of late what we realized is, we tender, suppose a flyover, saying okay, this 1000 cube of concrete, 1500 tons of steel, this much earthwork and all. Once the project gets completed, there's always a variation. Okay, 1000 cube of concrete will become 1500. 500 tons of steel will become 800 tons. Okay, why? Because probably design and estimation would have been wrong. So this is a problem for the government because it's very difficult for them to bring the additional cost. So what we suggested, I think it is one of my ideas long back, about 10 years back. We said at least for these flyover projects, important projects, let us tender on a lump sum turnkey. No variation. Contractor has to quote exactly the amount. He should not ask anything more. If the estimation is wrong, he must assess himself before quoting. Okay, saying this is what approximate quantities will come, and he must be very clear on his quoting, so that government need not come back on the variations part. That is how this document is done. A little bit of changes. So in this, the scope is, if you see typically in all the tender documents, you will have instructions how to fill this document and all this. Like any document, you will have instructions. Qualification info. This is where we are going to give inputs. What is the eligibility condition for anybody to participate in the tender? These are all for standard forms. He has to submit his eligibility, his conditions, his equipments available and all. These conditions of contract is standard. Okay, government will have set up conditions. This part is where we'll have to input it. Okay, for every project the scope will vary. For a road project it will vary, for a flyover it will vary, for underpass it will vary. Contract data is standard. Specifications will vary. For every project, we'll have to input specifications. Drawings, we'll have to. So what the changes is qualification information, scope of work, specifications, and drawings. Okay, we'll go what will be the briefly in each of them. All standard. Now, in a typical qualification information, we ask, okay, in the last 5 years, what kind of works you have done? Okay, there is a set of form. And similar works. Now, I missed one. see this. This is the qualification criteria that we have to enter. Normally in the state government, what they ask is, you must have done a similar project. This is what, 150 crores project, right? You must have done at least 50% of the value. Okay, contractor must have done at least one project of value equal to 50% of the project tender. So, 75 crores. Right? What is similar means what? Here is a flyover. So, you must have done a similar flyover. If it is a road project, it's a similar road. That's all. No difference in that. Then, you must have achieved a turnover. You know what is turnover? Every year, how much money you receive from the various projects. Right? It's a turnover. The turnover is 2 times the annual payments. Okay. So in a simple sense, if project cost is 150 crores and the duration is 1 year, so you need to have a turnover of 150 into 2. Suppose the project duration is 2 years. Then what we do? 150 divided by 24 months per month into 12. Basically per year. Okay. You understood? It is 2 times the annual payments. Okay. If the project cost is 150 crores, duration is 1 year, it is 150 divided by 12 into 12 months. You get 150 crores. The duration is 2 years, 150 divided by 24 into 12. The project duration is 3 years, 150 divided by 36 months into 12. This is standard. Okay, you cannot change. The formula is standard. You will have to only divide, multiply, and pick what is the value. Here we kept 2 years as a project duration. So 150 crores requires 150 crores of turnover. 1, 2, important. The third criteria is the document mandates that you must have executed peak quantities. In a flyover, what are the major quantity items will be there? A flyover project, concrete, steel, maybe expansion joints, bearings, then earthwork, piling, right? So we will have to define that 5-6 top items. Here, what we have done, this is going to be not an ordinary RCC, it is a pre-stressed concrete. So, pre-stressed concrete of 80% of the total quantity we have to input here. So, you must have similar experience. So, we got some X value, 80% of that is 10,246 cubic meters. Then similarly RCC, your pile substructure column is always RCC. Only the superstructure is pre-stressed concrete. Then you got retaining walls and approaches area. Then the pile foundations. Okay. We had like 200 something. So about 50% of that, the number here. Then earthwork. Then so only 3 parameters are important. One is turnover, similar work, and peak quantities. Term is peak quantities. Only 3 we have to assess and input here. Rest all the document remains same. But based on this, the eligibility, whoever is only eligible for this criteria, only they can bid and they are the only eligible contractors. See, the conditions of contract. Any contract document is subject to legal, right? Tomorrow some dispute happens, one can go to court. So that's why there are a lot of clauses will be there. How do you interpret, if the disputes are there? And then what is the decisions an employer can take? What are delegations? How to communicating? Whether you can subcontract to others or not, right? And what kind of personnel you have to engage at the site, what are the risks from the employer, the government department, what are the risks they will carry, what is contractor's risks, what kind of insurances he has to take, what kind of site investigation reports he has to give, then what kind of construction works the contractor has to do there, what is the intended completion date, if it's not completed what happens, what kind of approvals the employer will give, what kind of safety precautions you have to take at the site. They are all standard clauses. Okay. So these are all binding on the contractor as part of contract document, right? And then important is time control. Suppose 2 years is the time. How a contractor can complete within the 2 years? What kind of controls he will have? He has to give a program. If there is a program lapses, how do you get the extension of the time EOT? There is a procedure to do it, right? And if the delay, suppose the department orders some delays, okay, they may ask stop the work. Maybe election code of conduct came. Maybe some procession is happening for 3 days. Don't do the construction. All this is this. And then how do we do meetings, management meetings? It's very critical. Every week we must have a meeting between the contractor, consultant, and assess if there is any issues are there. Then how a contractor has to maintain this quality control. What kind of tests he has to do? If there are tests failed, not meeting the requirements, what is the next step? Okay, this how does he correct the defects? Right? If suppose he failed to correct, uncorrected, then what are the actions to be taken? So these are all binding. Tomorrow, some of you probably will work as a engineer in the department from the government side, and you will have to monitor the contractors' work. You must know all these conditions. Suppose you work in a company like us, where you are part of the PMC, Project Management Consultant, and you are at the site. You must again know all these things, right? Without you knowing this, you will not be able to impose the conditions on the contractor. Then cost control. You would have quoted 150 crores. Tomorrow, if it exceeds, what happens? In this case, we have fixed everything, lump sum and all. If it is an item rate, all this will come. Variations. How do variations? Who will approve variations? Suppose 100 m3 of concrete will become 150. Who has the power to approve? All this is detailed here. And how should he submit the payments, bills, right? Contractor needs payments, right? What is the format to submit the bill? How frequent, how interval, whether it's a monthly billing or is it a milestone basis, and then how the payments will happen, within how many days the government will pay the money to you. So these are all standard conditions, whether we take Karnataka government or NHA, it remains same. Suppose there are events which are beyond the control of contractor, right? Something happened there, for 30 days work is stopped. So how does the compensation happens to you, right? And taxes. Then very interesting thing is price adjustment. So what do you mean by price adjustment is, today when we did the estimate of 150 crores, we would have taken cement value of say per bag 400 rupees and steel price of say 60,000 rupees per ton. Next year the price may not be same. Either price would have gone up or the price would have come down. In that cases, we will have to compensate to the contractor on that price variation. There is a formula, again, standard formula in the document. All we have to input those values and get the figure, and then if the prices are gone up, we pay more to the contractor. If the prices are less, we pay less. In this particular document, we deleted that. The heading is there, inside we have deleted. We said no price variation is given. It's a fixed contract. You quote now, you take only that much money. Whereas in the item rate contracts, this variation comes into picture. Then liquidated damages. Suppose we say 2 years is the project period and it will not complete the work. Okay, and we have a conditions here that you will be put penalties for liquidated damages. Every day delay, how much, or every weekly delay, the amounts are fixed here. So that's called liquidated damages. Then advance payments means sometimes contractor can take about 5% of the money as an advance in the beginning itself for the project. And then what kind of securities he has to use? See, contractor takes this 150 crores project. What if he runs away? He gets the contract and he doesn't do any work and runs away. So there are securities he has to give. What in this contract, he has to give 5% of the project cost. Like 155% is what? 7.5 crores of bank guarantee has to give to the government while entering the agreement. Suppose he runs away next month, government can encash that 7.5 crores, right? That is called securities. And then it's called cost of repairs. Suppose contractor willfully did something wrong or he didn't correct the mistake. The department can get these repairs done by themselves and recover that payment from his costs. Then finally, all this done, how do you finish the contract, right? How do you know he has exactly constructed the way it's supposed to be? Right? It has to be matched with the drawing, sizes, measurements, width. You say 7.5 meter. You have to measure actually the tape. Right? Yes, 7.5 meter he has done. Okay, what if he has done 6.5 meters? Will you accept it? Okay. So there are again procedures. How to complete the contract, how do you taking out, there's a format. You have to take out the project from contractor. And then as-built drawings, right? This is very critical. I mean, you must know what is an as-built drawing means. We have designed and tendered with a drawing. Once he constructs, there may be small changes will be there. Okay? So we'll have to incorporate all those changes into the original drawing and make as an as-built drawing. That will be a copy with the department. Tomorrow after 5 years, we go back, we want to know something that as-built drawings. You would have seen English movies, right? Maybe some bomb in a building, they suddenly go to drawing of the building. You have seen? Okay, it's only in English movies, not in India. We don't maintain these drawings here. Okay, that's called as-built drawing. The as-built drawings, suppose in a building, you'll exactly know where is the AC vent, where is the exhaust, where is the utility pipe is coming, where the water pipe is going, where is the chamber, where is the manhole. That's called as-built drawing. That is why if something happens, the building first they see the drawing to understand. Similarly, in road or flyover, we need to have all these drawings with levels. Okay, what is the ground level? What is the finish level? What is the parapet? What bearings are there? How many expansion joints are there? What is the length? All that is a part of as-built drawings, and this is mandatorily contractor has to submit this to the government. And once he does all, final account is settled, or if something went wrong, he can be terminated. Either way, finally, you have to release his performance bank guarantee. Right? You would have given money, 7.5 crores I said, so it will be released later. Only when you do all this, this contract is completed. Till that time, his contractor is into the picture. As a consultant, we are also there. And we will similarly have a same kind of agreement with us also, as a DPR consultants also, government will have a contract. So everything is exactly same. Here we deliver reports, there they deliver construction project. And in all these tender documents, you will have one special conditions of contract. Okay? Like I said, all these are conditions of contract, which are all standard. You cannot tamper it, you cannot change it. Otherwise, what happens? Every engineer will change the contract the way he wants, and then end of the day, nobody knows what changes. So, to protect that, government has mandatorily said you cannot change any of this. If you want to change any of those contracts to suit your project requirements, only in special conditions of contract you have to edit it. Okay, put that clause and say, okay, this is not applicable. Like I said, this document we made no variation turnkey, right? So I'll show you that. This is whatever I explained in the words, it is in the right up here. So here I said we have to input this scope of work, right? It is project specific. So what is here? What is the design criteria he has to follow? Because it's a turnkey design, no variation contract, right? And what is the specifications for design and code should be followed? Order of precedence. Now sometimes what happens? You issue a drawing, right? And you do give an estimate also, BOQ. Item in the BOQ and drawing is not matching. So now confusion is which one has to be considered. That's called order of precedence. I'll show you how the order of precedence will be. See, all these codes has to be followed. see your order of precedence. Whatever design criteria specified in the tender document. If I would have said you follow IRC 37, that is the first order. So you have to only do as per IRC 37. If you are given something in the instruction of tenders, the first ITT, then special of conditions of contract, then GCC, then IRC, then code of practice. So any particular dispute, suppose in the drawing or in the document or estimate, if there is a doubt, you have to come back to here. If it is here, consider that. If it is not here, it is here, consider that as order of priority. Wherever it falls in, that is your first order of priority. No confusion. I said, okay, you have to measure, right? So, we would have already said in this flyover, we said overall deck width of the main floor is 19.3 meters. Okay, so he has to exactly construct 19.3, not less than that. We have a down ramp, up ramp, 6.5 meter width. Minimum carriageway width on the flyover, 2 into 7.5 meters. Okay, so this is where, as we as design engineers, will actually take from the drawing and we insert here. If you mess up something here, the whole project will go wrong. Okay. This is where the finishing also, like I said, you have to measure, ensure that everything is done as per this. Okay, so I told you we got conditions of contract, and then we are going to we are not going to change anything there. We will only give the supplements here. Suppose in the conditions of contract 17.17 and 26 there is a completion period of it there. All description of completion period. Here we input the intended completion date for the whole of the works is 24 months from the start date. Okay, so only addendums and modifications we do everything here. There is a defect liability period, again clause number 31. Then no changes from 31 to 40. In 41, we got liquidated damages. What is this liquidated damages? I said that for the delays penalties. What have we written here? 0.1% of final contract price per day. The delay is attributed to the contractor. You should know that our contract documents are very strict. But we see all our projects getting always delayed. So only problem is we don't implement the contract, we don't enforce the contract. And there I mentioned you can take an advance money also. See, so advance money 5% of the contract price. So there are instances happened earlier that contractor takes 5% of the money and then he will not even start the work. Sometimes he runs away. Then government said, all the government, okay, fine. If you have to give 5% of the money, take a 5% guarantee from it, bank guarantee, so that if he runs away, you can encash it. So, normally what we do in the specifications part, if it is a building project, it's a little different, where you will have to give specifications of every door, window, flooring, what material and all. In our roads and bridges, it's very simple. We always follow, this book, right? Orange book, seen, right? So it's very easy. We always mention all the specifications shall be as per MORTH, specifications of road and bridge works, latest edition. Sometimes during the tender time, the edition might come. So whatever the edition is available at the time of tendering is the latest edition. So we just have to follow that and all the relevant IRC and special publications. Nothing else we'll mention. We'll not mention what aggregate should be, what kind of bitumen should be, everything will link there. So actually it's very easy. Compared to any other projects, if you go for building projects, if you go for any urban infrastructure, lot of specifications you have to write. It's a tedious job. Here our job is simplified with this orange book. I think that should be enough on the tender document there.
Any questions, anything you want to ask? Yeah. Niranjan. They have some questions.
Yeah, please.
Go ahead.
So particularly with your NHA project that you presented, sir, it is, I think it's aerated dry area, uniformly graded sand. How you come out with stabilization of soil?
Say again.
How you come out with the stabilization of soil?
Okay, so on the Rajasthan project, right? Does sand fulfill subgrade characteristics? Huh?
No, sir.
Why?
Generally, it is uniform graded and there will be voids.
No. Who said? No stabilization required. Not required. Only we had an issue there with the sand dunes. You know sand dunes? Yeah, there we had to do some protections for sand dunes. Otherwise, the standard subgrade material only used there. No special protection.
Native material. One more thing is you mentioned about the moth or any standards, the latest that should be adopted of latest version. In case if the construction is started and it is just by started, it's a new.
No, not applicable. All IRC code specifications at the time of tender will only govern. Okay, not after the tender if suppose new change comes, is not applicable. Unless otherwise client wants to implement that and then there's a variation comes. Otherwise it's not bound on the contract.
One more thing, sir. Of course, there are human errors that can occur in the preparation of DPR and all. Is there any room for to get corrected after starting of construction?
Well, see, you are absolutely right. So in any civil engineering profession, mistakes do happen. If there are no mistakes happens, if there are no failures, probably we don't need so many civil engineers. But those mistakes shall not be intentional, right? And if any mistakes happens in DPR, normally during the construction it will be found and then we will always address it. But then there will be also strict penalties for those mistakes. If it is unintentional, it's fine. It cannot be intentional or negligence. You cannot design a payment without knowing what is a CBR or a wrong CBR. Those things are not acceptable. Nowadays you get terminated and you get blacklisted. Consultants will be 2 years you will not be eligible for bidding.
In fact, it is the same question that Nitin Gadkari also keeps asking. That DPR consultants, many times they are off the mark, particularly in road projects.
Absolutely. So it is actually it's a dual-edged sword, sir.
Yeah.
So government, the way they operate consultants, the consultants, the way they treat projects is all interlinked. But I am very sure with my 15 years experience, if you are passionate and you take accountability and responsibility for what you are doing, 99% you can always do a good DPR. But sometimes it happens, people will take it as a simple kind of business. Okay, anyway, I do submit something, take money and go. You will end up in all the mistakes. Because it never ever in our projects, I can proudly say, we never encountered such a major mistakes or blunders.
See, actually, this connect between the stakeholders plays a very important role. One are the owners of the project, another the set of people who survey the whole thing, third is a set of people who design and do the DPR, and fourth and more importantly, the agency which executes. if there is no perfect understanding between these, one very simple example that we have is a very living example. A Taj hotel in Mumbai, which faces the sea. Any hotel which faces the sea should be facing sea, right? Only thing is that because of a lack of understanding between agencies, it so happened that it is built 180 degrees differently. Now the back of Taj Hotel is facing the sea. That was not the idea at all. That was not their objective. Just because people who surveyed and gave inputs, they forgot to mention the lines properly, directions properly. And the person who designed, and finally one who executed it, thought that this is the way it should be done, and they realized it later. Even today, it's a living example of lack of coordination. Taj Mumbai doesn't face the sea. I mean, it's a very small example, but still.
We do such mistakes always. So, see, I'll tell you, for example, you don't study the soil properly and then design the pavement.
Yes.
Mistake.
Common mistake.
If you are not calculate the high flood levels properly and design the bridge levels, mistakes, right? So, and junctions, curves, blind spots, these are all design mistakes.
And in cities, the most common problem is where your service lines have gone.
Yeah.
Nobody knows. Nobody has even the drawing of the existing service lines.
I was mentioning that.
Yeah.
So that's what and even the traffic scenario sometimes it's very misleading in the
Correct. So, I mean, and that's why I said, so mistakes do happen, but mistakes should not be intentional, mistakes should not be from the negligence point of view, right? Otherwise, concrete strengths will fail, there are ways to do it, all that. But basic mistakes should not happen. Yes, nowadays, the road accidents, we are the world's topmost country, right, in terms of road accidents and number of deaths. So, more onus on us on the designs and all. Anything else? 5 minutes.
So we've come to the end of the session, and thank you so much, Ratnakar. It was very elaborate. I think the students have kind of understood a lot in your lecture, and we wish you would revisit our institution and keep giving us such thoughtful lectures. Thank you so much. And just as a very small token of our gratitude, it's a very small token, I would mention it again. I request Ramchandra sir to hand over this to you.
Yes.
Thank you so much.
Good. Wish we'll have more interactions here.
I would love to. So I always believe that when I come and interact with students, it's not that I'm teaching you something. Actually, I'm learning. Okay, so at least we never had this opportunity when we were studying. At least we never had this opportunity that people from profession used to come and talk.
Yeah.
At least now you have this option, and you're all smart compared to what we used to study, your syllabus, your subjects. So thank you for this time, opportunity. Love to come back.
Yes, sure.
So, is there lunch?